everyone. In this lecture, we're going to be talking about the exponential distribution. Now, the exponential distribution is very similar to the Poisson distribution. Now, remember, a Poisson experiment is any experiment where you repeat the experiment over and over and over again until you get a desired result. So, for example, I have this quarter, and I might be interested in how many attempts it's going to take for me to get a heads. It might take 1 attempt. It might take 2 attempts. It might take like 100 attempts for me to get a heads. Now, there's a 50% chance I'm going to get it on the first attempt, a 25% chance I'm going to get it on the second attempt, and a 12.5% chance I'm going to get it on the third attempt, and so on. That's the Poisson distribution. But if you notice there, the variable for the Poisson distribution is discrete, meaning I can't really tell you what the probability of me getting a heads after 3.5 attempts is going to be because I can't flip a coin 3.5 times. The variable there is discrete. The number of trials is a discrete variable. The exponential distribution is concerned with continuous variables, specifically intervals of time. So let's be more specific with the definition here. The exponential distribution is often concerned with the amount of time until some specific event occurs. For example, the amount of time beginning now until an earthquake occurs has an exponential distribution. So consider, like, for example, you're in California, let's say. Earthquakes happen all the time, but no one knows when they're going to happen. They could happen at any random time. Typically, they happen, several times a year, but you have no clue of when they're going to happen. And so what the exponential distribution is concerned with is calculating the probability that will happen, let's say after 3 months, or within the first 6 months, or within the first year, or within the next 2 years. That's the exponential distribution. That's the kind of questions that the exponential distribution can help with. Now, to give you guys another example, consider a light bulb. A light bulb can burn out at any point in time. Typically, they burn out after about a year, and it really depends on what light bulb you have. But they could burn out in a day. They could burn out after like 3 years. Some light bulbs you can get lucky with. And that's what the exponential distribution can help explain. The idea is very rare amount of the time will a light bulb burn out within the first month. Some of them will burn out within 2 months, and some of them will burn out after 3 months of use, and so on. And so the idea is the longer you wait, the more likely the light bulb is going to probably burn out pretty soon. And that's what the exponential distribution can help with. Here's another example. Consider length, minutes, long distance, business, telephone calls, and the amount of time in months a car battery lasts. It can be shown, too, that the value of the change that you have in your pocket or purse approximately follows an exponential distribution, which is kind of interesting. Values for an exponential random variable occur in the following way. There are fewer large values and more small values. For example, the amount of money customers spend in one trip to the supermarket follows an exponential distribution. There are more people who spend small amounts of money and fewer people who spend large amounts of money. Exponential distributions are commonly used in calculations of product reliability or the length of time a product lasts. So, for example, that light bulb example is a perfect example where you would use an exponential distribution. Or how long your car is going to last. You don't know. You don't know how many miles it's going to last for. It could last 200,000 miles. It could last 500,000 miles. It could last for 50,000 miles. But the idea is there's this average, and it might not reach the average. It might reach further than the average. And you can use exponential distributions to figure out the probability of certain events happening. Anyways, I hope this makes sense. Thank you guys so much, and I'll see you in the next lecture.